Okay, so today we start a new chapter in class 9. That is your chapter 9, force and laws of motion. So we'll start with the question 1 on your tuition note, okay, and then we'll go and see how much we can do. Okay, for the first question obviously is, what is force? Okay, write on your tuition copy and listen to this. Now you see here, suppose this ball is rolling on the field, on the ground, on a flat football field or flat table, and then on the table it's rolling, and you bring your hand and then stop it. So that hand that you bring is called push. You put it in the path of the ball with a slight push. So what did you do? Push, slight push like this. Just put, also that's called slight push on a rolling, write it down, ball, brings it to rest. Just write it down, you will get it. Then the ball is now stationary. Now you go and push the pull the ball or push the ball. You pull it like this. You go and do like this and pull it. Let's say this time you pulled it. So on a flat table you pull the stationary ball. So pull on the stationary. Stationary means now the one which is at rest here. Now you put a slight pull on the stationary ball, brings it back. Okay, brings it back, right down, so you get it, brings it back to motion. Okay, so this push that has caused the rolling ball to stop, and the pull that has caused the ball that has stopped, stationary ball, to come back to motion, this push and the pull that has changed the moving ball to rest and bringing back the resting ball to motion is called force. Okay, so let us read the answer for that. What is force? Your tuition note definition. In simple words, a push or a pull on any object or body like a ball is called force. This one is a basic definition of force we even know in class 6, 7, right? But a technical definition is like this, is the same, not hard. Force can therefore be defined as an influence, okay? An influence like push. Influence here means the push and the pull, which tends to move a body or object which is at rest to motion, or which tends to stop a body. Well, suppose a body is stationary and you push, it starts moving, or a body which is moving, you block it with a pull or push, it comes to rest. Okay, so which tends to move a body at rest, or which tends to stop a body in motion already, or which tends to change the direction of motion also. Sometimes it did not be even stopping. You pull like this and you pull a slight push on the right side of the ball. The ball will continue to roll, but the direction of rolling will change. So that pull which has caused the not the pull or the push that stop the rolling ball or bring the resting ball to motion, or the pull that has changed the direction of the rolling ball, these three, all these are called force, okay, which tends to change the speed and direction, even the change the speed and direction of the body. This is called force. Okay, now let us go to the next question. Now once we get what is force, force is simply an influence or push and pull that brings a resting body to motion, or a moving body to stoppage, or a moving body to cause the direction to change, or even the speed of the body to change, is called force. Next important question is question number 2. Balanced and unbalanced forces. Let us get this concept. 2 types of basic forces clearly with an example. Write it down. Difference between balanced and unbalanced forces. Let us say we have a wooden box, a wooden rectangular block, or something like that, rectangular block. This is the block, let us say. We have tied this end to a rope. Let us indicate it as X. This side we have tied it to another rope, Y. Now if you pull it from, this is the object wooden block A, let us say. So suppose you pull only this side, the rope X, the box will move towards the right, right? But if you pull only from the left Y, it will move towards the left. So this pull on the right that has caused it to move to the right, the wooden block, or the pull on the left that has caused it to move to the left is called unbalanced force, okay? Because it is partially moving either on the right or on the left. Or even if you put a rope up at the top and pull it up, it moves up, that is also unbalanced force. It is moving down, that is also unbalanced force. But suppose you ask two boys to pull, one here, both of them have equal force, let us say. So they pull with equal force, but since both of them are pulling with the same amount of force, the wooden block will neither move to the right nor to the left. It was stationary in the beginning, it will remain to continue in that state of rest. So those kind of forces, two or more forces acting in various directions, but causing no change in the original state of the object. Like if the object was at rest, it remains at rest. If the object was already moving, it continued to move with the same speed. After application of the two, three forces also, those two, three forces that combine, that are not able to change the state of rest to motion, or the already in motion bring it to rest, then those are called balanced forces. Balanced means a group of forces that is acting on the same body at the same time, but not causing the change of state. Means if it was in rest, it continued to be in rest. If the object was moving with 5 km/h speed, after application of the two, three forces also, the object begins or continues to move in that same speed without being influenced by the application of the two or three forces, and such are called balanced forces. Okay, so let us go and read now. You'll understand it, right? So here, question number 2, with an example, sorry, differentiate between balanced and unbalanced forces. There on your tuition note in the figure, body A is attached to strings X and Y. Strings means simply small ropes, okay? If X is pulled, which is on the right, the body moves to the right. Sorry. Similarly, if the string Y is pulled, the body moves to the left. Because it is moving partially to the right or to the left, these are called unbalanced forces. But if the body A is pulled from both sides with equal forces, mind you, the body does not move an inch. It stays there at rest. Such forces are called balanced forces. So you have understood the concept. Now the technical definition is like this. Next paragraph. Thus, when forces acting simultaneously means at the same time, the word simultaneously means at the same time, okay? Suppose I drop the pen here right now and another boy on the top floor also at the same time drop the same point. You call that as both of us drop the pen simultaneously, okay? So at the same time. Thus, when forces acting simultaneously on a body does not bring about any change in its state of rest. If it was in rest, it continued to be in rest after application of the two, three forces. Or if it was in uniform motion, 40 km/h, after application of the force also, there is no change in the uniform motion, it continues in the same speed, then such forces acting simultaneously on that body, which is not causing the change, which is not causing the resting body to come to motion or the body in uniform motion to change its speed or come to rest, such forces are called balanced forces. Example, balanced forces. A boy unable to move a heavy box because his pushing force is balanced by the friction force of the ground. Now, let us say there's a big box and a boy tries to pull it, but it does not move 1 inch. That's called balanced force, because the force with which he is pulling the box is exactly balanced by the friction force between the heavy box and the ground. So pulling force and the friction force has cancelled each other out, and there is no extra force to pull the box, so it's not moving from rest to motion. That is balanced force, okay? Now next, example of unbalanced force. When forces acting at the same time, again, the same box, which the single boy was not able to pull, he called 2 more boys and 3 of them pull. Now this time, the force applied by the 3 boys are greater than the friction force, so the box begins to move. That is an example of unbalanced forces. Unbalanced forces always brings a body body at rest to motion, or a body that is already in motion to change its speed or to come to rest, okay? When forces acting simultaneously on a body bring about change in the state of rest or of uniform motion in a straight line, then such forces are called to be unbalanced forces. Let us read again. When forces acting simultaneously on a body bring about a change in the state of rest or of uniform motion in a straight line, then such forces are called to be unbalanced forces. Example, 4 to 5 strong boys together are able to move a heavy box because their pushing force becomes greater than the friction force of the ground on the box. Okay. Now next, question number 3. This is important. Simple experiment, but let's do it. Question number 3. Write it down on your tuition note. Galileo deduced that objects move with a constant speed when no force acts on them. Explain with an example. Okay. Write it down. Galileo is a scientist. Deduced means, the word deduced means found out. Found out by experiments is called deduced. That objects move with a constant speed, means same speed, unchanging speed, when no force acts on them. So we're going to see this with an experiment. Let me read through it once so that we can explain after that. Now you go there in your tuition note, page 107. Galileo deduced that objects move with a constant speed when no force acts on them. In order to show this, what did he do? Let us see. He observed that when a marble rolls down an inclined plane, its velocity increases and its velocity decreases as it climbs up. Okay. Figure C shows a marble resting on an idle frictionless plane inclined on both sides. Okay, inclined on both sides. Here Galileo argued that when the marble is released from the left, it rolls down and goes up to the opposite side to the same height from which it was released. If the inclinations on both sides are equal, the marble will climb the same distance that it covered while rolling down. If the inclination on the right side plane were gradually decreased, then the marble would travel farther distance till it reached the same height from which it was released. He did this experiment and found out like this from the left plane. If the right side plane were ultimately met horizontal perfectly, then that is, the slope is reduced to 0, the marble would continue to travel forever, trying to reach the same height that it was released from. The unbalanced forces on the marble here are 0. In other words, an unbalanced external force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. This observation of Galileo gave rise to Newton's first law of motion, which is important. However, in practical situations, it is difficult to achieve a zero unbalanced force. This is because of the presence of frictional forces acting opposite to the direction of the motion. Thus, in real-life practice, the marble stops after traveling some distance. The effect of the friction force may be reduced by using two techniques: a smooth marble or a smooth plane and a lubricant on top of the planes. Okay, so this is what Galileo did and found out. So let us do the same thing. He put an inclined plane. Inclined plane means exactly like this. Look here, rolling down plane. Draw it along with me. So this is an inclined plane where you can slide down, and there was a ball that was rolled down from here like this in this direction. So here it rolled down, figure A. Then here, there on the opposite side, let us say, and there's yes, so okay, so here like this. So what he found out was the ball which is rolled down at, let us say here, 60 degree, and this also inclination is equal, means 60 degree. So at an angle from the with the ground horizontal. So the ball was rolled down from this height, let us say 10 meter. This was also 10 meter. Then he found out that as it rolled down and as it climbed up to the same height as this one. From this side, you drop from 10 meter height from the ground. It rolled down. If it is a perfect inclined plane, it rolled up to the same height on the other side. But he noticed that while this ball was rolling down, the velocity began to increase. But when it reaches here and begins to climb up, the velocity decreases. That's what he found out. Now you see, he had a perfect plane. Imagine a perfect plane means horizontal plane, okay, means no inclination up or down, okay. And then here he dropped it out from a height like this ball. Then suppose this is 30 degree, then this side also, let us say, equal 30 degree. Then suppose this height was this side was 10 meter. As he rolled down, the ball rose up to the same height here, 10 meter, traveling the same distance if the angle is equal. Then this one was same, and he gradually changed the angle, this side lesser, 20 degree. Then he found out that what happened was, this is 10 meter, let us say. He found out that now this time the ball rolled down and the inclination is lesser 20 degree. So he found out that the ball began to travel more distance. When it was equal inclination 30-30, distance down was 15 meter, then this also 15 equal, and the height is 10, same to this height. But when the angle of inclination was reduced on the right side, the ball rolled down and began to travel more distance. Here 15 meter, but here 30 meter, till it reached the height 10 meter, the same to this side. Sorry. So he found out this one. Then finally, when the inclination was removed to 0, means there is no more inclination, and became a perfect horizontal plane which has no friction, perfect horizontal plane, the ball began to roll in this direction and continued to move forever till he put his hand to stop it. Then only it stopped. Until and unless he didn't put his hand, the ball continued to roll forever. But this experiment is imagined to be in a perfect horizontal plane where there is no friction, okay. But in real life that is not possible because there is some air force, friction on the surface. Perfect plane is not there, therefore it will move a long distance, but it will come to stoppage by itself. But if there was no unbalanced external force, the force alone here was there in perfect horizontal plane with no friction, then the ball would be moving forever for millions of years. That's what he means, okay. This proved that from this one here, the last one, that if there were no outside forces like air force or friction force in the football field, when a player kicks a ball, travels long distance because it's a perfect horizontal football field, but comes to stoppage. Why? Because the ground is having rough surface, friction is there, and air force is there. But if there was no air in the atmosphere and there's no friction on the football field, the ball will continue to roll for millions of years, okay. That is true. So from this experiment, Galileo found out that an object that is moving with some speed will continue to move with the same speed forever till some outside force like air force or friction force come and stop it. So this one is there. And he also found out that if a body was rest, if I put this duster here at the top of this one, and after 20 days also I come, it will be exactly in the same position, means it will be in the rest. So this tendency of an object to remain like this until and unless somebody come and apply a force to remove it, the tendency of the object to remain at rest, which was at rest, and the tendency of the ball to roll on the horizontal plane forever till somebody put an outside force to stop it, this tendency of all objects in nature to remain in rest if it was in rest, and to continue in the same motion if nobody applied a force, is called inertia, okay. It's called inertia. And this discovery that an object that is put at rest like this will forever remain in rest until somebody come and apply a new force, or a body that is rolling on a perfect horizontal surface will continue to move forever until somebody apply an external force, this tendency of a body to remain in rest if it was in rest, or continue in motion if it was in motion forever, is called inertia. And this discovery of inertia gave rise to the first law of Newton's law of motion. So Newton's first law of motion got its derivation. The idea came from Galileo's discovery. Okay, this one. So let us go there. Now, in nature, the football field has some friction. There is no perfect plane, so the ball will stop rolling after some time because of friction. How can you reduce this friction force on a perfect horizontal plane? You can apply lubricants. One technique. You can use a smooth marble, not rough one. And then you can use, number one, smooth marble you can use. Number two, you can make this surface very smooth. Number three, you can apply some lubricants like powder and all to make it, to reduce the friction. So those are the three techniques of reducing friction on a surface. Okay. Question number 4. Go to question note, page 108. Newton further studied Galileo's idea. So Newton's discovery, this one we discussed just now, was an important discovery, because with the help of this, Newton was able to give us the 3 laws of motion. Newton further studied Galileo's idea. That means he did not start with his own idea. He took the idea from Galileo because it was correct, and he worked more upon it. Idea on force and motion, and presented the 3 fundamental laws that govern the motion of objects, known as Newton's laws of motion, or Newton's 3 laws of motion. Yes, tick there, yes. Now, Newton's first law. Newton's first law is actually Galileo's discovery. So let us just read through it. Question number 5. State Newton's first law of motion. Newton's first law of motion states that an object remains in state of rest or of uniform motion in a straight line unless compelled to change the state by applied force. Let me break it up here. If an object was at rest like this, this duster will remain at rest like this forever unless somebody come and apply a new force. This tendency is called Newton's first law of motion. The other side, like 2 sides of a coin. I'm just breaking it down. The tendency of an object at rest to remain at rest forever until and unless an external force is applied is Newton's first law of motion. Like 2 sides of the coin, there is one side of the coin, 50 paisa coin. The other side of the coin of Newton's law of motion is that a ball that is rolled on this perfect plane will continue to roll for millions of years forever till somebody come and apply an external force to stop it. This tendency of an object at rest to remain at rest forever, and for a body in uniform motion to remain in that same uniform motion forever until and unless compelled to start moving or to stop in the case of uniform motion by an external force, is called Newton's first law of motion. Okay, well, let us read once more before we go to the next one. Question number 5, page 109. Newton's first law of motion says that an object remains in a state of rest, like the duster here, forever, or it will be in uniform motion in a straight line forever, unless compelled to change the state, means to change the state of rest to motion or motion to rest by an applied force, means outside force. Okay. Now, why is Newton's law of motion also called law of inertia? Question number 6. The tendency of an undisturbed object to stay at rest. This duster has a tendency to stay like this forever at rest. Okay. Or a body in uniform motion to keep on moving in that motion. Okay. And the same velocity is called inertia. So what is inertia? This tendency of the duster to remain in rest forever and the rolling ball with uniform velocity to remain at that same velocity forever. This tendency of moving body to continue in motion and the resting body to continue in rest, this tendency of all objects in nature is called inertia. Okay. Write some examples of where Newton's first law of motion is called inertia. Sorry, now go back to question number 6, last sentence. This is the reason why Newton's first law of motion is also called law of inertia, because it's the same, right? Inertia means the tendency of a resting body to remain in rest forever, or a moving body to remain moving with the same speed forever. It's called inertia. And Newton's first law is also the same thing, saying the same thing, that is, a body continues in motion if likes to continue in motion forever, or a resting body likes to be in rest forever, Newton's law also say like that. Inertia's definition is also the same. That's why Newton's first law of motion is also called law of inertia. Okay, write some examples where Newton's first law of motion or law of inertia is in operation in daily life. Question number 7a. We read now, we'll understand. Number A. Sudden application of brake slows down the car, but our body tends to continue to in the same state of motion due to its inertia. Inertia is what? Tendency of a resting body to remain in rest, or a moving body to continue moving in the same straight line. Right? So let us see. Or in the same pattern of motion. Now, when you are traveling in a car and you the driver suddenly applies a brake, the driver and the passenger also would like, since it is moving along with the car, when brake is applied and car stop, the car has stopped, but because our body was just a moment ago moving with the car, it would like to continue moving. Because of that, even though the car has stopped, upper part of our body move, and if the brake is applied too suddenly, then our head may go and hit the dashboard there. That is the reason why car companies give you seat belts here that will belt your body, and then when the car applies brake, we know that inertia law is in operation, so our body will continue to move in motion even though the car has stopped moving, and so that may cause accidents. So because of the seat belt, because of that, seat belts are provided so that our upper part of the body will also stop along with the car. Okay, so that is one area where we see that because of the law of application of law of inertia, seat belts have to be provided in cars. A sudden application of brake slows down the car, but our body tends to continue in the same state of motion due to its inertia. Inertia means the tendency of the moving body, our body, to continue moving. This may cause us to collide with the panels, means the dashboards in front, causing injury. Seat belts exert a force on our body to make the forward motion slower. Thus, seat belts help prevent such accidents. You got understood, right? Number B. As we are standing on a bus like this, and the bus suddenly stops, our body was just a moment ago moving with the bus. So even though the bus has stopped, our upper part of the body, our legs have stopped with the bus, but our upper part of the body, because of inertia, means its previous state of moving, continue to move even if the bus has stopped. That is the reason why when the bus stops, our body is still moving due to inertia, and our upper part of the body continues to move even after the bus stops. Okay, so let us read through. As we were standing on and the bus begins to move suddenly, our upper part of the body tends to continue in its state of rest. Oh, this one is the ulta of what I explained. The bus is stationary. Suddenly the bus driver starts the bus. Our body is at rest. The bus is also at rest. Suddenly it starts moving. Then upper part of the body is also still in rest, but the bus has started moving. Because of inertia of rest on our upper part of the body, it would like to continue in rest, but the bus has moved. That's why our upper part of the body is pulled backwards. That's what it's here. I thought it is brake. Sorry. As we were standing on the bus and the bus begins to move suddenly, our upper part of the body tend to continue in its state of rest, the rest, inertia of rest. Due to its inertia means a previous state of rest before the bus started, causing a tendency to fall backwards. Okay, next. As we are traveling on a car on a straight line, we are in a straight line motion with the car. But when the car takes a turn to the right or left, what happens is the car has changed direction, but our body is still in a straight line motion. So it would like to continue in the straight line motion. So the car has turned circular, but our body is still in, because of inertia of straight line motion, our body is still in the straight line motion. So it is, our body is shifted towards one side of the car, right? So as a car turns sharply, our body tends to continue in its state of straight line motion due to its inertia, causing a tendency of our body to slip to one side of the seat of the car. Okay. Finally, question number 8. A body at rest will remain at rest unless acted upon by an unbalanced force. Prove this is true with an example. Okay, so here you take a carom board, like this. People play with striking with a striker. Circular dice are there, so you pile it up like this on the carom board and strike it very hard with the striker. What you will notice is that the bottommost coin of the carom will slip out. right? All this coin before it was hit was at rest, inertia of rest. But when you strike the lowest one with a hard hit, only the lowest coin comes out along with the movement of the striker, but the rest of the coin just falls down in the same spot. Why? Because it was at rest. The carom has a tendency, the carom coin pile has a tendency to continue in rest. Only the lowermost one, which has experienced external force, moves out. The rest did not experience much force, so it continued to be in rest. See, so that is an example that shows us that a body that is at rest will like to continue in rest unless you apply an external force. So let us read through that. Only the carom coin at the bottom of the pile gets removed when a fast-moving carom coin called the striker hits it. Once the lowest coin is removed, the inertia of the other coins make them fall vertically on the table. This proves that instead of going a distance, it just falls in the same spot. This proves that a body at rest will remain at rest unless acted upon by an unbalanced force. Okay, question 8. We'll continue the next part in the next class. So we have today video 1, question number 1 to 8. So tuition note, you write down on your tuition copy, and then whatever you've scribbled, and then pages 106, I think 106 to 110. 106 to 110. Okay, so this is your portion for today. We'll continue in the next class. Okay, this chapter, after two or three more classes, we will be having numericals, so listen carefully. Okay.